Hello everyone and welcome back to Kanayi's AI. Today we are going to demonstrate how large language model can be customized by using RAG, Retrieval-Augmented Generation. To make this demonstration practical and relatable, I am building an app, Chatbot app for Automobile Service Center by combining LLM with RAG. The obvious question in this particular case, we have already LLM. So why do we need a RAG on top of it? So we all know the LLM like ChatGPT, BERT and Gemini, these are all very powerful. And these models are prepared by using large amount of public data, which is giving very good responses when we question in generically, right? So when we ask a domain type of question or your internal database question or your internal business related question, so the responses may not be factual, right? So this particular reason, so we used to customize the large language model. So large language model can be customized in multiple strategies. So in case we said prompting, which is nothing but giving the responses and the questions we are keeping like a standard references. So this is one important method, but sometimes this also may not get proper result because there is no training happens in this particular approach. So we have another technique, fine tuning. Of course, this is a very good method, but this fine tuning requires a lot of training data. Of course, we are using a baseline LLM. On top of it, we are going to take our custom data. Those custom data is going to train and merging with the existing model. So this is a tuning or kind of a style change or behavior change of a model. So the another method, Retrieval-Augmented Generation. So here comes the difference that makes the beautifully application like RAG combined LLM. So what exactly happened in RAG? So RAG is nothing but which connects an external document. So there are two steps happening in RAG. First, this system retrieves the relevant information from your external records like a vector database. Once the relevant information is captured, the LLM is started generating responses which is strictly based upon this retrieved document from your external document. So in short, fine tuning is changing the model that may not give always factual responses, but this is not changing the model, but the model connecting with the data by using this particular architecture. So this is the fundamental of LLM combined with RAG. So we are going to start with the demonstration. In this case, as I mentioned, we have a case study from Automobile Service Center. We have documents, warranty record, service packages, pricing policy, etc. etc. So you can see here, we have the text response of service pricing, warranty guidelines and service packages, etc. etc. So rather than going into the records every time, so we are going to build a conversational AI agent by using LLM with the RAG. So when the user give a query, the machine is going to give the responses. So we are going to build this model. So let us go to the demonstration code. So initially we are going to connect the collab with the drive. So that is possible by mounting the drive by like this. So whatever the documents available in the folder, you can see your documents are available, internal records are available in this folder like a text document. So we are mounting the collab with the drive. Once the drive is mounted, we are installing the required libraries. In this case, we are taking the libraries like transformer and sentence transformer, phrase, etc. etc. Transformer is to load and run the LLMs. And sentence transformer will generate the numerical embedding from the text responses. And this is very important. This basically finds the similarity searches within the generated embedding. So these libraries are already created and imported. Now after that, so we are loading the document from the drive. As I mentioned, we have data path where all the documents are available and loaded all these three documents related to pricing, warranty and the service. Once that is completed, we are going to create the documents from document embeddings. We can say that sentence transformer we imported, and we imported face. So initially the sentence transformer created text chunk into the numerical embedding, which can go for computation. Once the embeddings are created, the next is the very important steps, finding the similarity searches and get the relevant information from the searches. This is very, very important to get the most relevant pieces of information when a user asks a question. Again, this step is very crucial because it enables the semantic searches. Rather than just finding the keyword and matching, it's producing the intent which can understand the business. Right? This is done. So after that, using the transformer pipeline, we are loaded the baseline model. In this case, we have Flan T5 LLM. So we are going to utilize this Flan T5 LLM. As I mentioned, we have different process. So we are combining everything in this RAG underscore query function that brings everything together. From it's taking the user input, it encodes the user question and retrieve the relevant information. And of course, this sentence transformer converted into numerical embeddings. Then face is converting into the semantic searches and getting the most relevant document from the face. Then the prompt given to the LLM, this Flan T5 model generated the answer based on the retrieved information. So this is what exactly happening in the entire process, right? So this particular process we are completed, and this is nothing but just testing. When user is giving a query like this, what could be the responses? Of course, this is very going and getting mostly a good result. So we are going to make an app which is nothing but Gradio based app to validate our query. So we are making a simple chat interface. So in that we are taking a chat underscore rag underscore query, which is again another function that wraps our rag entire logics, and that deploys on a web-based interface where user asks questions and see the grounded answers in real time. This makes the solution very, very good to demonstrate for both technical and non-technical audience. So to validate this particular application, so I have some certain queries. So I'm just going to take the query. We have an interface like this. So I'm going to ask question here. This is the place where you can ask question. So I'm asking one by one. So there are some defined question with me. I'm just taking one by one so that we can save our time. The first question I'm going to ask to this bot. So my car has completed 10,000 kilometers. What services is recommended and what does it include? Let's see how fast the response is producing and whether we are getting the output or not. So we are getting the output. So this is basically giving all the information, and we are going to see the second question. Second question, like a follow-up question only. So I'm just giving the prompt once again, user query. So you can see here, we are getting the responses very quickly. Yes, we have a regular services for this wheel alignment. And for testing once again, I have another question. Of course, whoever is interested to validate this, definitely we will give the code and all setups, right? So far this is working very good. So this validation is also completed by using the Gradio. Now let's summarize what we built today. We implemented a complete LLM plus RAG pipeline. So we are using a real world automobile service center for testing it. We saw why we plain LLM can hallucinate sometimes because customization is not possible, because normal LLM will not understand what exactly your internal document is. So fine tuning may not be possible. Again, retraining is required. So I'm going for RAG, which is the right solution because I have a lot of documents which is external in the drive or somewhere. So RAG connecting the LLM to the real documents, and finally the Gradio helps in validating and demonstrating the solution effectively. So this is the biggest takeaway nowadays. If your AI needs to be answered a business specific or factual question, so RAG is not an optional. This is the correct architecture. So if you found this video relevant, stay tuned with Kanayi's AI Lab. with more relevant AI content. So thank you once again for joining this session.